Throughout history, humanity's greatest leaps have come from new ways of thinking. The printing press, the steam engine, the internet, each transformed how we share and process information. Today, December 3rd, 2025, marks the dawn of the quantum age. For decades, quantum computing was a distant dream, a theoretical marvel. We imagined machines that could solve problems beyond the reach of any supercomputer, operating by the strange rules of quantum mechanics. Now, that dream is becoming reality. Building a quantum computer has been one of humanity's toughest challenges, controlling the delicate states of atoms, shielding them from the world. But the pieces are finally falling into place. This isn't just an upgrade, it's a paradigm shift, like moving from an abacus to a supercomputer. The quantum boom is when this technology steps out of the lab and into the world, rippling across industries. Its impact will touch medicine, science, finance, and security. We're about to speak to the universe in its native language, quantum physics. And the conversation is just beginning. To grasp quantum computing's power, let's start with the basics. Classical computers use bits, zeros or ones like a light switch on or off. This binary system built our digital world. Quantum computers use qubits, which can be 0, 1, or both at once thanks to superposition. Imagine a spinning coin. While in the air, it's both heads and tails. Qubits also have entanglement. Two qubits can be linked so that changing one instantly affects the other, no matter the distance. Einstein called it spooky action at a distance. This lets quantum computers explore countless possibilities simultaneously, not one by one. A classical computer with 300 bits is powerful, but a quantum computer with 300 qubits can represent more values than atoms in the universe. This isn't just faster, it's a new kind of computation. Quantum computers can tackle problems of complexity we once thought impossible. They're not just an evolution, they're a revolution. The rules have changed, the possibilities are staggering, and we're only beginning to explore them. Just as quantum computing neared a breakthrough, the field hit a wall. The Great Quantum Pause of 2024. Labs worldwide halted operations, not from disaster, but from mounting technical and ethical challenges. The main culprit, decoherence. Qubits are fragile. Tiny disturbances destroy their quantum state. As systems grew, error rates soared, making results unreliable. The industry realized more qubits weren't enough. They needed better, more stable ones. The pause was a time for deep reflection and rebuilding. Researchers shifted focus from quantity to quality, prioritizing error correction and stability. Teams redesigned chips, improved shielding, and developed smarter algorithms. The silence was unnerving, but it laid the groundwork for real progress. The pause became the foundation for the breakthroughs that followed. When labs powered up again in late 2024, the results were astonishing. Qubit stability had improved dramatically. Coherence time stretched from microseconds to milliseconds. This stability unlocked practical real-time quantum error correction. New codes entangled physical qubits into robust logical qubits, detecting and fixing errors on the fly. Quantum computing matured from unreliable experiment to dependable tool. Reliable hardware enabled longer, more complex algorithms, accelerating discovery. Progress was exponential. What once failed now succeeded with precision. Rival companies began sharing foundational techniques, fueling open innovation. The pause wasn't a setback, it was a launchpad. In 2025, quantum computing leaped forward with unprecedented force. Now, in 2025, we've reached the quantum boom. True quantum supremacy on real-world problems. Quantum systems are solving scientific and commercial challenges faster than any classical supercomputer. The key fault-tolerant logical qubits, made possible by recent error correction breakthroughs. Hundreds of robust logical qubits now power computations that would take classical machines billions of years. The era of noisy, intermediate-scale quantum devices is over. Fault-tolerant quantum computing has arrived. Multiple hardware platforms, superconducting circuits, trapped ions, photonics are advancing in parallel. Each excels at different tasks, from drug discovery to machine learning. Access is democratized. Cloud platforms let anyone run quantum experiments. Experts in finance, logistics, and science are unleashing a wave of innovation. Quantum computing is no longer just science, it's a tool for industry. The future is here. Practical quantum computing is shaking every sector. In cybersecurity, quantum computers can break today's codes, sparking a race for quantum-resistant encryption. In science and medicine, quantum simulations design new drugs and materials at the atomic level. We're already seeing quantum-designed catalysts and treatments for diseases like Alzheimer's. Climate science is getting a boost. Quantum models predict weather and climate with unprecedented accuracy. Quantum optimization is redesigning power grids and logistics, slashing energy use and emissions. Quantum AI is finding patterns in data that classical AI can't, revolutionizing diagnostics and finance. The partnership between quantum and AI is unlocking new levels of creativity and insight. The quantum boom is more than new computers. It's a new era of discovery. The world is changing fast. Quantum computing has sparked a global race for technological and economic leadership. The US leads with massive investment and private sector innovation. China is pouring billions into quantum research, excelling in quantum communication and secure networks. The EU and India are rapidly scaling up, focusing on collaboration and national initiatives. Despite progress, quantum computers won't replace your laptop. They're specialized tools for complex problems. Scaling remains a challenge. These machines require vast, intricate infrastructure. We need new skills: engineers, algorithm developers, and quantum-literate professionals across every field. Public understanding is essential as quantum reshapes our world. This is a historic shift in our relationship with information and reality. The quantum age is here. The future belongs to those who are ready. Are you?